Okay, we will learn about percentage composition of compounds, empirical and molecular formulae, and then these are the learning outcomes. Yeah, to determine the percentage composition of compounds from given data, and also to determine the empirical and molecular formulae of a compound from given data. Okay, if I have one sachet of 3-in-1 coffee, what is the composition of 3-in-1 coffee? Do you know the composition of 3-in-1 coffee? Not only coffee, right? What else? The compositions of 3-in-1 coffee. Hello?
Yes, Miss.
Yeah. What are the compositions of 3-in-1 coffee?
Coffee.
Coffee. What else?
Sugar.
Creamer.
Yeah, sugar, coffee, and also consists of
sugar, coffee, and cream.
Yeah, it can be creams, it can be milk. It can be cream or milk. Yeah. 3-in-1 coffee consists of sugar, consists of coffee and milk. Yeah. For example, yeah, there are 10 grams of coffee. Not only coffee, also 13 grams of sugar and 12 grams of milk. So it means the total mass in one sachet is 35 grams of 3-in-1 coffee. Can you calculate the percent compositions of coffee, sugar, and milk in 3-in-1 coffee sachets? How to calculate the percent compositions of coffee? How to calculate percent composition of coffee?
For the coffee would be 10 over 35 times 100%. Is it like that?
Yeah, it's correct. Yeah, by 10 divided by 35. Yeah, times 100%. So it means the first coffee is 28.5. And how about sugar? How about
13
sugar?
of 35 times 100%.
Yeah. Okay, what's your name?
Joanne, Miss.
Okay, Joanne, good for your response. Okay. And how about milk?
12 over 35 times 100%.
Yeah. Okay, good, Charles. 12 over 35 times 10, 100%. So the total is 100. And also, the chemists too need to conduct analysis in order to find out how much of each element there is in a new compound. They do so by finding out the mass of each element in the compound. the chemists also do the same things that we have done before. And then how to find the percentage compositions of a compound? Yeah, this is the equations. Percentage by mass of an element in a compound equals number of atoms of the elements in the formula times AR of the elements over MR of the compound. Over MR of the compound times 100%. Yeah, for example, what is the percentage by mass of hydrogen presence in water? What is the molecular formula of water?
H2O.
Molecule, yeah,
H2O.
H2O. Okay, good. H2O. So it means percentage of hydrogens. How to calculate it?
1/3 times 100%.
1/3.
3.
Why 3?
Wait. If H.
Nah.
Is it
Number
2?
of atoms of hydrogen. How many hydrogen atoms?
2 times 1.
Yeah, 2, right? There are 2 hydrogen atoms and only 1 oxygen atom. So it means 2.
2/3
or
times
you
100.
need to write complete. Okay. Repeat it again. So number of hydrogen atom. Times AR hydrogens over MR H2O. So equals how many hydrogen atoms?
2.
2 times
1.
Yeah, because the atomic relative mass of hydrogen is 1 over MR of H2O. We already know from the last topic 18. So prepare your calculator. Calculate it. 2 divided by 18.
1/9. 1/9 times 100.
Yeah, 1/9.
11.
Or 0.1.
11.11111.
Yeah, times 100%.
11.11111%.
Oh, in percent. Okay, 11. Point. Is it correct? Correct or not?
Yes.
Yes. Good. And how about percent composition of oxygens? How many oxygen atoms? Number of oxygen atoms.
8.
Huh?
8.
How many oxygen atoms? No.
Oh, 1.
Number of atoms. Yeah, just 1 oxygen atom. So times AR of
8.
oxygen. Huh? AR of oxygen 6, 16. Over MR H2O, same. 18. Please calculate. Yeah, is it times? Is it times 100%, right? Don't forget. Times 100%. Is it also times 100%? So the result is
88.89%.
88.9.
0.89%.
Okay.
Percent.
So the total when we sum is 100%. Okay, can you understand how to find mass of an element in compound? Understand? Okay, go next for percent composition of molecule. Percent of water in cobalt 2 chloride hexahydrate. COCl2 6H2O. How to find the percent H2O? Hello? Percent H2O equals number of, hello students, kids, number of H2O times molar mass H2O divided by over. Hello? What is the equation to find? Yeah, MR. MR or CO, Cl2, 6H2O times 100%. So we need to know number of H2O. How many H2O in this? 6. This one, right? 6.
6 times 18.
Molar mass of H2O.
18.
Yeah, 18 over. Let's calculate MR. MR is cobalt. Cobalt. The R of cobalt is 59.
59 plus
2 times
71.
Yeah, plus 71 or 35.5.
Plus 6 plus
108.
6 times 1.
6 times 2. 6 times 2 plus 16.
6 times 2, yeah. 6 times plus
16.
Plus
it
16.
can be right 6 times 18, right? 6 times 18. Okay. And the total is 59 plus 71.
238.
100.
238.
38. Okay. 238. Times 100%. Okay, the answer is
45.38%.
45.38.
38%.
Okay, 38%. Okay. Okay, can you understand? to find percent water in the molecule of hydrates. Okay, go next. Subtopics 9.5 empirical and molecular formulae. Yeah, do you know ethanes? Have you learned about hydrocarbons in kimia subject? Ethane. Have you learned hydrocarbons, alkenes, alkanes? No? Not yet?
Not yet.
Yeah, actually the ethanes, yeah, have the full structural formula. Carbons and hydrogens. Hydrogens, and hydrogens. So, from this full structural formulae, we can write the molecular formulae of ethane. The molecular formulae of ethane is C2H6. Who can explain what is meant by molecular formulae? What is molecular formula? It shows what molecular formula?
It is the formula that shows the exact number of atoms of each
Yeah,
element in
exact
the molecule.
number of atoms. Yeah. How many carbon atoms? 2. How many hydrogen atoms? 6. And then we will compare with the empirical formula. The ethane is CH3. Why CH3? What is empirical formula? For example, C2H6, its mean consists of 2 carbons and 6 hydrogens. I make it simple by divided by 2. Divided by 2 also. Only consists of 1 carbon and 6 divided by 2, 3. 3 hydrogens and only 1 carbon. I can write it as CH3. CH3. So what is meant by the empirical formula? Empirical formula. So
Is the simplest formula of a compound?
yeah, the simplest form that is, or the simplest ratio of the compound, the ratio composition of atoms in a compound. We can call molecular formula as the actual formula, the actual number of elements in a compound. And then empirical formula, we can say it as simplest formula of the compound. So the exact number of atoms in each element in a molecule or compound. But the empirical formula shows the simplest ratio of different types of atoms in the compound. Okay, you can see the table. Acetylene C2H2. So we can divide it by 2. Comes only CH. C6H6 divided by
6.
CH. Ribose C5H10O5 divided by 5. This is the simple ratio. And CO2 can divide it again. No, cannot, right? Cannot divide it. So the molecular formula of carbon dioxide is same with the empirical formula of carbon dioxide because it's already the simplest ratio in carbon dioxide. And from the empirical formula, for example, symbolized by AXBY, the molecular formula is AXB times IN. N equals relative molecular mass over relative mass from empirical formula. Relative molecular mass same as molar mass of the compound. Okay, go next to the examples. Determine the empirical formula of hydrogen peroxide, H2O2.
HO.
Yeah, HO divided by 2 N3O6.
NO2.
NO2.
Okay, NO2. Magnesium iodide.
MgL.
Huh?
MgI2.
Yeah, same, right? The molecular and empirical is same. Cannot divide it anymore. Glucose C6H12O6.
CH2O.
CH2O. Okay, divided by 6. CH18. Divided by
2.
2, yeah. So the empirical formula is
C4H9.
yeah, C4H9. Good. C4H9. Okay, let's go to the next question. Determine the molecular formula of a compound with the empirical formula CH2 and molar mass is 200 gram over mole, ARC12 and ARF19. How to solve this problem? Determine the molecular formula. So it means CF formula. Empirical CF2. So what is the molecular formula? We can symbolize as molecular formula equals with CF2 times N. And to know the molecular formula, actually we have to find what is N, right? How to find N? We can use these equations. N equals relative molecular mass relative molecular mass over relative mass from empirical formula. What is relative molecular mass?
50.
What? Charles?
50.
50? 50, Charles?
Is it 50, Miss?
Is it correct? No, not 50. Be careful. Relative molecular mass. Yeah. Is it same as molar? Molar mass. Molar mass or MR? MR of the compound. Listen with MR. This one, MR. So, the relative molecular mass is 200 grams over mole. 200 grams. And the relative mass from empirical formula actually is the MR of CF2. Is it equal with the MR of, is it MR of CF2N? Compound. MR of CF2. What is the MR of CF2? Please calculate it. Joan? CF2
Yes, Miss.
Joan? Please find MR of CF2.
CF2. Is it 12 and
12.
19? 12 plus 19 is 31.
Huh?
12 plus 19 equals 31, right?
Not plus 9, only 19. How many fluorine atoms?
19 times 2.
19
So
times
38.
2, Joan.
38 plus 12 is 50.
38 plus 12. So 38 plus 12?
50.
Yeah, 50. Okay. So Charles, 50 is the relative mass from empirical formula. Not mass. 50. 50 over 50. 50 gram also over mole. So N equals 200 over 50. What is N?
4.
Yeah, 4. So the molecular formula of the compound is CF2 times
4.
4. The molecular formula is
C4.
F8.
F8. Okay. Can you understand how to determine the molecular formula from empirical formula? Okay, go next. Yeah, for the last sample questions. A sample was analyzed and found to contain 400 carbon, 7,100 hydrogens, and 53.29% oxygens. If the molecular weight of the compound, molecular weight, what is it? Molecular weight. What are the empirical and molecular formula? How to solve this problem? Yeah, there are 400% of carbon, hydrogens, and oxygens. What is meant by persons? Person is same as divided by 100. So in shape means that 100%, yeah, equals with 100 grams. So it means 40% carbon means 40% gram of carbon, 40%. So how to find how many carbon atoms? We need to find how many moles carbon. What is meant by 1 mole of carbon? What is the mass from 1 mole of carbon? What is the mass of 1 mole of carbon? Who knows? Total mass 1 mole of carbon is 12 gram. 12 gram. So we can divide it, cancel gram. 40 over 12. Please calculate it.
3.33.
3.33. And then go next for hydrogen, please. Hydrogen, how to find it? Celine, please. Celine? Hydrogen. How about hydrogen, Celine? Can Celine? Please. For hydrogens, yeah. 6.71 grams. So 1 mole hydrogens equals with the mass 1 mole hydrogens. Same as relative atomic mass of hydrogens. AR hydrogen is
1.
Yeah, 1. So it's 1 gram. So it equals 6.7. And then go next for oxygen, please. Oxygen. Christine Angel. Oxygen. Hello, Christine.
Yes, Miss.
Oxygen.
53.
Yeah, 53 point 29 grams times how many grams in 1 mole? Christine, Angel.
16, Miss.
Yeah, 16. Good. Christine, Angel. So it equals. Please calculate it. 53.29 over 16.
3.33.
Yeah, 3.33. So we need to make it this to become simplest ratio. How to do it? To make it simplest ratio. Divided by simplest.
3. By 3.
Also divided by 3.33. It also divided by 3.33 divided by 3.33. So what is the simplest ratio?
1.11.
1.11. 1.11. Okay.
Then 2.9. 2.02.
Yeah, 2.02.
And the next one is also 1.11.
So we can make it simple as 1, 2, and 1. This is the simplest ratio, right? So it means, what is the empirical formula? The empirical formula is the simplest form shows how many carbon atoms? 1. So it means only 1 carbon atoms. And then 1 atoms, the simple form is 2 hydrogen atoms in empirical formula. And oxygens, 1. This is the empirical formula. Empirical formula. Empirical formula is CH2O. And how about molecular formula? Molecular formula is, we need to find, and molecular formula is CH2O times, we need to find N. How to calculate N? N equals molar mass. What is the molar mass of the compound?
180.
Yeah, 180.16 gram over mole. And then relative mass from empirical formula, CH2O. Find
24.
the MR of what, Charles? 12, 24,
30.
or 34?
24, miss.
Is it 12, 16, 30, right? 30. 12 plus 2 plus 16.
30.
Yeah, 30. 30. So N equals, grams over mole. N equals 180 over 40 equals with the number 6, right? N equals 6. So the molecular formula is, you can change N with 6. What is the molecular formula of the compound?
C6H12O6.
C6H
CH12.
12O
6.
O6.